Oh yeah, let's finish out these exercises in style. We are now going to find the absolute maximum and minimum of a function on a closed interval. Let's roll. Number 6, y equals minus x squared plus 6x on the interval -1 to 5. If you prefer, you can rewrite that as -1. Less than or equal to x, less than or equal to 5. And again, the exact instructions are find the absolute maximum and minimum of this function on that interval. So you can always start out with the statement, and I'm going to say it out loud again. The absolute maximum and minimum will occur either at the endpoints, x equals -1, x equals 5, or where y prime equals 0 or does not exist. Or you could say at the critical numbers of the function. So let's find the critical numbers first. That's going to be where y prime is equal to 0. So the derivative is minus 2x plus 6, not bad at all. We set that equal to 0. Subtract 6 from both sides and divide by -2. So x is equal to 3. So that's a critical number. That's what we now have. We've got a critical number. So now our candidates that we're going to try, and I like to write candidates, almost like you're doing an election here, would be x equals -1, 3, and 5. These values now we just need to test in our original function. The highest is the maximum, the lowest is our minimum, the lowest y value, and the highest y value that is. So I do y of, this doesn't mean multiply, it means plug -1 into the function for y. So that's going to be minus -1 squared plus 6 times -1. So -1 squared is 1. The opposite of that is -1 plus a -6. So that's going to be equal to -7. All right. Y of 3, again, we're plugging 3 into this function. That's going to be the opposite of 3 squared plus 6 times 3. And we're going to simplify that. That is 3 squared is 9, minus 9 plus 18 is 9. Ooh, very nice. And then y of 5, let's see what that gives us, our other endpoint. That would be the opposite of 5 squared plus 6 times 5. Well, that's going to be equal to -25 plus 30, which is 5. Therefore, our maximum, our absolute maximum is 9, and our absolute minimum is -7. And to be formal, you'd make the statement, our absolute minimum is -7 and occurs at x equals -1. Our absolute maximum is 9 and occurs at x equals 3. Not bad, right? Not bad at all. All right, on to the next one. Find the absolute maximum and minimum of the function on the given interval. All right, it's going to be the same instructions for all 4 of the problems here. So again, we take the derivative and set it equal to 0. We want to find the critical numbers, right? Because the absolute max and min occur either at the critical numbers or where the derivative is equal to, or the endpoints, right? So it happens either at the endpoints or the critical numbers. So critical numbers where the derivative is 0, 3 times 1/3 is just 1, x squared minus 9, and the 1 becomes 0. Ooh, that's nice. This will never not exist. How about that for a double negative? But it is equal to 0. And so we solve this out. I get x squared equals 9, or you could factor it. Remember, when you take a square root, it's plus or minus. So x equals plus or minus 3. Those are our critical numbers, -3 and 3. So our candidates for the absolute minimum and maximum, candidates, hopefully I spelled that right in the last page. Let's see. Yeah, I did. That's good. So the candidates would be x equals -6, an endpoint, -3, 3, the other critical number, and the other endpoint of 5. Endpoints, critical numbers. All we got to do now is test them. Y of -6. Now I plugged this into my calculator ahead of time because I wanted to spare you the amount of time here that it would take. You plug in -6 into here and into here, and you end up with a relatively nice number, -17. Then if we plug in y of -3, again, I'm not multiplying, I'm just plugging -3 into the function. That ends up equaling out to, let's see, well, y of -3, 19. All right. Then we do y of 3. Well, y of 3, plugging it into here again, that actually ends up also being -17. Ooh, we got a tie. You could have 2 places where there's an absolute min. You could. See if that ends up being it. And then y of 5 is -7/3, or -2 and 1/3. A lot of people don't do mixed numbers, so I'm just going to do a decimal, -2.333. 3 decimal places for the A, B, and BC exam, unless your teacher says otherwise. But the ABBC exam, that's the rule. The lowest y values here, negative 17. So we've got the minimum, and 19 is the max. Now, the minimum is negative 17, and it occurs at both x equals negative 6 and x equals 3. The maximum is 19 and occurs at x equals negative 3. That's it. This, it's just an endpoint. Oh well. All right, so on to the next one. We got two more. Find the absolute maximum and minimum of the function on the given interval. Little trig for you, huh? Let's do it. Again, we need critical numbers and endpoints. So the absolute maximum and minimum will occur either at the endpoints, 0, 3 pi over 2, or the critical numbers on this interval. So we take a derivative, see what that is. Derivative of sine is cosine of x. The derivative of cosine is minus sine. Minus a minus sign is plus sine x. Neither of these functions can ever give us a derivative where we get a 0 in the denominator. Sorry, I should just say neither of these functions will give us an undefined value, so the derivative will exist. So we just set it equal to 0. Now how do you solve that? You could do some unit circle logic, or you could go a little further than that. You could say, when does cosine x equal minus sine x? Okay, we could go with that route. And we could go from here and divide both sides by cosine. When does 1 equal to minus sine x over cosine x? That's dividing both sides by that. It's up to you how you want to do it, but either way, you've got to have your unit circle down pat. Remember, we're only going from 0 to 3 pi over 2. So I'm only considering values from 3/4 of the unit circle. All right, what do we got going? Well, if we take a look at this, when is this equal to 1? This is equal to 1 when sine and cosine have opposite but the same values, because that's an opposite sign of that. So pi over 4, they have root 2 over 2. That'll be negative 1. 3 pi over 4, cosine's negative, sine is positive. That's going to do it. Right? So we got 3 pi over 4. Again, because cosine is negative root 2 over 2 there, and sine is root 2 over 2 there. Negative root 2 over 2 over negative root 2 over 2 is 1. 5 pi over 4 down here won't work. They have the same sign. And so what that's going to end up being is a negative 1. Right? You'll have negative root 2 over 2 over negative root 2 over 2. That ends up being negative 1, right? Because you've got negative and negative. So only at 3 pi over 4. And you could also look at it, where does cosine and sine have opposite signs on that interval? Here. Right? You could have done it there. Next, we've got our critical number. We've got our endpoints. So our candidates, again, this is just me. I like to list them out. Our candidates are x equals 0, 3 pi over 4, and 3 pi over 2. Nice. All right, so again, we're going to evaluate them. The highest value is our maximum. The lowest value is our minimum. F of 0, well, that's sine of 0 is 0, minus cosine of 0, that'd be minus 1. It's equal to negative 1. F of 3 pi over 4, let's see what we get there. Well, sine of 3 pi over 4 is a root 2 over 2, right? It's right over here. Cosine, remember we're doing minus, is negative root 2 over 2. Oh, okay. That's going to be equal to, well, this is going to be plus. That ends up being 2 root 2 over 2, which simplifies to root 2. All right, that might be important. So far, that's our maximum, that's our minimum so far. Let's check our endpoint. F of 3 pi over 2. Well, that is equal to sine of 3 pi over 2 is negative 1, minus cosine of 3 pi over 2 is 0. That's equal to negative 1. What that means is we have a shared minimum and one single maximum. So this is our max. This and this is our min. So our minimum is y equals negative 1. It occurs at both 0 and 3 pi over 2. And our maximum is the square root of 2, which occurs at x equals 3 pi over 4. Oh, it's beautiful. Absolutely beautiful. Uno más. One more problem. Let's do this. Find the absolute maximum and minimum of the function on the given interval. Don't mind if we do. Okay. Again, we're going to look for the absolute maximum and minimum, and we know that it will occur either at the endpoints, negative 1 and 8 in this case, or at a critical number, where the derivative is 0 or does not exist. Let's do this. Critical number, here we come. H prime of x is equal to 6 times 2/3, x to the negative 1/3, and that simplifies down to, well, this is going to be 4 over x to the 1/3. When I do my calculations with my function, and I set it equal to 0, or does not exist, I want my negative exponent out of there. Otherwise, I might erroneously come up with a critical number that's not right. Might. In this case, I'd be fine either way. You'll see why. So this will never equal 0 because in order for a fraction equal 0, the numerator needs to equal 0, and it doesn't. It's 4 all the time. So that's out. However, for the derivative to not exist, we would need the denominator to equal 0, and it does. X to the 1/3 will equal 0 when x equals 0. That's our critical number, right? So a critical number that we're going to plug into our candidates. So the candidates for our our absolute max and min. In orders, -1, our endpoint, 0 is a critical number, and 8. Now you could have 15 candidates, just depends on how many critical numbers there are. I've limited the number of critical numbers in these exercises so that it just wasn't an insane amount of algebra. Right? Okay, so all we now need to do is plug in our values. The highest is our maximum, the lowest is our minimum. H of -1 is 6 times -1 to the 2/3. The cube root of -1 is -1. Squared is 1 times 6 is 6. Next candidate, so exciting, h of 0. That's not hard to do, right? 6 times 0 to the 2/3. Well, the cube root of it's 0, okay? It's just 0. So that can't be a maximum because 6 is higher. And we'll go h of 8. Let's see. I can hardly bear the anticipation. 6 times the quantity of 8 to the 2/3. The cube root of 8 is 2. Squared is 4. Times 6 is 24. All right. So we've got a maximum. The highest y value is 24. The lowest y value is 0. Therefore, the absolute minimum is 0 and occurs at 0. The absolute maximum is 24 and occurs at x equals 8. Done. Done. And keep in mind, I've gone over in all these videos how to justify this formally. So if you've got that pesky, tough professor or teacher who wants you to justify answers, that'd be me. I got my kids ready for the A, B, and BC exams early. You should be justifying all the time. But if you're in a class where you don't have to justify, then this work suffices. All right, y'all. I will see you in lesson 3-2, of course. Psych for it.